Hello guys, welcome back to Root and Out. This is Diljit here. We are continuing with our REST programming series, and today we are going to build a web application security scanner. And this is part 1 of the series because this may take more time. So I'm planning to divide this video as 2 parts or 3 parts. I don't know how long it's going to be. But we will be learning some more REST, especially async REST, how to make use of async when we are developing web application vulnerability scanners or any cybersecurity tools. Async REST is a must-have that you should learn. Unfortunately, I can't go deeper into async REST. I'm planning separate video exclusive for async REST because it's very deep and very in-depth topic. But we will be discussing some of the basics of async REST and how to make use of that in our scanner. And the vulnerability that we are going to scan today to find developing in the scanner is for XSS. And let us see what it is and how it works and how to exploit XSS. First, so if you are not familiar with cybersecurity terms, XSS is refers to cross-site scripting. It's a vulnerability where attackers inject malicious scripts into any trusted websites. These scripts execute in victims' browsers. So that will allow attackers to bypass access controls. Maybe it is getting confused if you are hearing its theoretical part. I will show how it can be exploited in real time. Not in real time. I mean, if it's there in any of websites, and how attackers can make use of that. So it has mainly it has 2 categories. Reflected and stored, and this another category is called DOM based XSS, where JavaScript DOM is manipulated for this. The working is same. Normally in reflected XSS, the attacker crafts a malicious link with a script payload. Then the victim clicks the link, then the server reflects the script back to the browser. So the script executes in victim's context. That's the main thing. So as an example, if a vulnerable site has this issue in one of the query strings that is not properly validated, then this should reflect back to the victim, and the victim will run the script on their logged in session. If they are logged in or whatever activity the victim is doing, it will get executed there. Same time the attacker can do actions based on the payload that he is crafting. And the difference between these two are, this one is just reflecting back to the user, and the attack vector will be only one user that is using the current session or the current browser. It is like sending the attacker has to send the link to every user or victim that he is planning to attack. But in case of stored XSS, normally it comes like the website will have an option to save the information back to the server's DB. So it will be permanently there as an attack vector. So it doesn't matter who is going to visit the site. Every time when the user visits the site, it may get affected, depends upon the user roles implemented on the site. And I don't want to get you confused on that. I will show how it works, then it will be easier for you to understand. And why it is dangerous means it can do a lot of stuff. Means the attacker can do a session hijacking, he can do an account takeover, and defacement, keylogging. Keylogging is definitely based on the browser side, and it totally depends upon how smart the attacker is crafting the payloads. So I'm going to show you a small demo on this one. I'm going to create this is a session hijacking demo. What I'm going to do is I'm going to create one payload and into the signed user based on the DVWA application. And if you are interested more to learn about this one, try to set up a lab using the DVWA application. It's very good to start learning. So I'm going to do the same thing. I'm going to use the DVWA application for the demo. I'll be crafting one JavaScript, the script that is going to steal the user session, and I'm going to get it. Normally these things happen using phishing, but here I'm going to show you what's going to happen if the victim is going to click the link or use the link. So here after the exploitation demo, it will be more clear for you how it works. So let me show you the demo for this one. So for showing the demo, I'm going to I have hosted my DVWA here, and I'm going to log into this session, and for the testing purpose, I'm just making the security for learning purpose. So you can try with the different security levels according to the level that you will learn how to bypass the different levels of this one. So for the first demo, let me see here. If you see, there's a function in this website that help you to do some it asks you the name, and it just prints here as the result. So I just gave test, and it gave me back the test here. So here on a normal user perspective, is it just printing the name back, but an attacker perspective, attacker can test how the script is getting, he can inject different type of characters and see how it is getting interpreted by the browser. If it's properly validated, it will not get affected. So imagine that I'm going to inject a script that I have already saved the demo script for you. This script is what is doing. It's just using the JavaScript fetch method and sending the current session cookie to the attacker machine. So what happens here, just imagine I'm going to inject the script here, and if you ask me how the real thing is going to work, you can see the URL here. It's a direct get method, and it's a query string parameter, so attacker can easily craft this URL and send to the victim, and at the time when he logs in, so if he clicks on this link, he will send the cookies and session IDs to the attacker, so the attacker can log in from his machine. So just imagine I am just doing that here, and I have an attacker machine. I'm going to set it here. Just check my IP, and my IP is this 98, and I'm just setting up my attacker server, and just come here and change to my it's already 98. I already saved it. So imagine that I'm going to do the submit here, this as a submit, and you can see this, it clearly created a link for me. The attacker can make use of this link to attack other users of the same website. What happens here is, see, nothing reflected back here because the script that we injected is treated as a JavaScript instead of text. That's a problem here. And if you see the source code of this one, where is that? it will be here. Oh, what was that name? Fetch. You can search for the fetch, that will be easier. See, this script tag is not encoded, it treated as a script, JavaScript itself. So the browser executed that because the application failed to encode this script tag properly. So I will show how to how the application can prevent this after changing the difficulty of security here in this application. In this case, we already ran this, and if everything went well, we would have got, see, here we got the session ID. The PHP session ID is the session ID name. So this %3d is a URL encoding character, so it might be from here to up to this %, and I'm copying this one, and from the attacker machine now I'm trying to log in. So it is, I think, 192.168.1.198 slash what else, I forgot the path. Yes, DVWA. DVWA. Oh no. Sorry. HTTP 192.168.1.188 slash DVWA. Just imagine I know the pages here, and maybe the first page, just try to access first page, index.php. So when you are asking for the index.php, now it's redirecting to the username password. But if we inject the session ID that we already got, what is going to happen is, where is more tools? Yeah, go to developer tools, and on the application go to cookies, storage, under storage cookies, just select this website, and see there's a session ID value here. Just replace it with the session ID that we got from the victim, and just enter. Now if you try index.php, see, you can easily get into the machine, get not into the machine, get into the website session that the actual victim is using. So what happened now is, we just stole the session using a script, and we logged in on behalf of the user. So it's kind of impersonating or session ID hijacking. You can call whatever you can call it. It is something that this is how the XSS stuff works in a real time. And yeah, fortunately most of the modern web frameworks by default blocking it to some extent, but still it is depends upon how the developer deals with this one. This is not completely an input validation failure, but mostly it is an output encoding issue. So how to block this one? Before that, let me shut down this machine, otherwise my memory will make issue. So now this is the complete failure, because it executed the script that we injected. But if you set up the code level as impossible, and if you try the same, I think I copied, and I'm copying the same. And now if I try to inject it here, see, now it is reflecting, it is just printing that to the text box that is provided. How it happened in previous case, actually it was not treating this as a text, it was treating it as proper JavaScript to run. So now what happened, if you check the source code of this and try fetch, see, now it is properly encoded. All the characters, the less than symbol was encoded as ampersand LT semicolon. So now this is properly encoded, and so the browser is not handling this as a script, instead it treated it as a text. And this is what expected from a secure application point of view. It shouldn't execute the script that is injected into the application. Hope you got what exactly this one is and how we are going to automate this stuff. So before automating, let me close. We have to make use of another tool to analyze the application. So we'll be using that application to analyze the login, because in this application there are different levels that you need to know. Even though we can convert this the scanner to a common scanner that scans any website, but for the demo we have to go through several methods that is going to be exclusive for DVWA. So let us start the app, just say web app scanner and cd web app scanner. So for this, we'll be making use of some of the crates that is available from Rust. These are the necessary things that we need for our application. Just keeping it here. I don't want to waste time on this one. And the Rust analyzer is showing some error here. I think it's better restart. Sometimes it will work only if we restart it. Let me see that. Okay, now we can. So the first thing we need to do is, as you see, we have to log into the application. For analyzing the application, actually there's another tool called bug suite. It can be used for testing the application. It has it has built-in scanner for the paid version, and I don't know whether it is available for the community edition, but it has a paid version. The paid version has a vulnerability scanner that helps you to scan the application automatically. But for our task, I think it is available here also, but no, it's not. I don't know. Let us intercept this one and log into this. It is a proxy application that is going to help us to analyze the application. The modern version has a built-in browser into that itself, so it will be easy. You don't need to configure any external browser. So this one is the browser from this one, I think. No, this is not the browser. You have to click on this button. Yeah, this is the browser. Just off, then just log out and log in from here. It might be because when I was testing the stuff, I already logged in. That was the session ID might have been saved somewhere. That's what it was showing there. Now I'm trying to log into the application, so just forwarding the request and go to history and check what we did on the login, and this is the login, the URL for that, and the parameters are at username, password, login, and a user token. User token is also there. That's an extra stuff, so you need to find out where that user token came from. So go to the first login request, get request, and analyze the response. Maybe user underscore token. Actually, yeah, it is here. The user token is here on the first response. That means the first get request to this one. So before login, we have to, when we are going to automate this one, we had to do a get request to the same login PHP. Then we have to fetch the user token from the response. Then you have to use the user token on this post request. So there are tasks to do. The first thing, okay, for the time being, let us close this. This also eats memory a lot, and so now we have to do a lot of stars, but first make use of the request, and we'll be making use of the async operations, not the blocking line. So just use the normal client. I think I can switch off my AI assistant, or it will be a mess. Use the other crate that we are going to use is the the scraper one. Scraper, and from this we'll be making use of HTML and selector. And don't worry about these grades and its helps. Again, the REST analyzer is showing issue. Let me close it and open it again, and let us go to the browser, and don't worry about the, I already did refer this one, the scraper one. It has clear examples of how to fetch elements from the response. So we'll be utilizing the same thing here. Maybe this will be a good example that we can make use of. Let us try that. So now we need whatever we want as the grades. So now we have to do the proper the REST way. So I'm going to, so I already mentioned it here on the architecture part. So this is going to be the struct that we are going to use to maintain stability on the scanning. Actually, the most effective REST way is to use struct plus trades, but I'm avoiding trades now because it may be confusing for some of you. We already covered how to use trades in one of the shell coding video. So that video covered how to make use of trades, and dynamically we can create objects at runtime. So now we are going to do the structurally design, but definitely in real time you should be following the trade based architecture. That is very effective. So let us make the client as client, then the base URL that is going to be, let it be a string. Now we have our web scanner struct ready. Now the next thing is you have to implement this. Implement web scanner. These things we already explained what and how it works. So the first thing, create an associated function that will help us to initialize our struct. So it's going to return, it is going to return self. This self is nothing but it's a shortcut to refer to your struct itself. It is good in a way that suppose in future, if you want to change the struct name, you can easily name the same name here, web scanner here, but if in case if you're going to refactor this code and renaming something web scanner to something else, then if you miss out some area of the places that you want to rename, then it will be a mess for your code. So it's always good to use self. It starts with the capital letter S, that refers to the struct itself. Now we are going to initialize the client. For initializing, and the first thing we need to know is we have to, just because we need to log in first and do the operations, we have to maintain a session. For that, it is supporting a function called cookie store, and if you set the function as true, this will help us to maintain the session, and then call the build, and it's actually it returns a result. It's a asynchronous result, asynchronous function, so it's a future result. You have to either expand it or don't try to use unwrap in these kind of situations. Just say, because unwrap will, anyway it will get panicked, but you will not get any clarity on what happened, and especially the Rust error is really hell to read. So better to use some message that will help us to identify this. I can say HTTP client init failed. So if it's going to be an error, it may get panic, but at least you should know what happened. So the next thing we have to do is you have to return the struct. Oh, sorry, this is the syntax. For returning the struct, just use the self keyword and the client, then the base URL. Now I'm going to specify the base URL how it should return, because we got it as a reference string, so we have to convert back to string, since we are going we will be using this string, this is an owned string, so we already covered all these things. So if you are not able to follow this, please refer the first video where we covered how these things works. Now we have initialized the web scanner struct. The next thing we need to do is we have to do the login. So now the login method is going to be actually is going to be the method, the struct method. So the first parameter should be self, and that makes this method is going to, that just tells that it's a method for the struct. And in terms, this is called associated method, that is associated function, that is going to be utilized for initializing this web scanner. This is going to be a method, this is going to be called methods, struct methods. because we can call this method just by using the struct name dot the function names. So the next thing we may need the username, and again that is going to be a string, and password, again that is a string. Then what we are going to return from here, so this should be like, let it be the result type, and in case of just be unit type, and in case of error type, we are going to send this to the box using the dynamic dispatch. And I think better if I do on my AI stuff. I don't know why the analyzer is not starting yet. Okay, without analyzer it's very difficult to just memorize all these stuff. Let me restart it, maybe this time. I don't know, sometimes it does like that. Hopefully this time. Oh no, again. Let me do it manually. Okay, let us continue the code. I will try it from my memory. So theoretically, we just checked what we need to do this for logging. Just say logging into DVWA and oops. The first thing that we want is let the login URL, of course, and let it be. We already have the base URL, so, and it was login.php, I think. It was login.php, so login.php. Why I'm doing this one is because I already tested before preparing the video, so I know how these things work. So that's why I'm doing like this. But from scratch, if I do start from the video, it will be a very long video because I have to solve a lot of errors while we are making this. And here we need to mention this one, what this one is. So that is our self.base URL. And there's a function available in this one if you mess up with the I don't know why the analyzer is not helping. I think better I turned on my AI, so that will help. Otherwise it will take time to memorize everything and do it. So the login URL is set up. So now what we need is we have to get do a get request to that function, right? I mean to the page. Yeah, it is doing it from the memory. I think it's I already did login page, and I forgot one thing. We are going to make use of async function here, and everything is going to be asynchronous in this one. So the get method is simply just get the login URL, send to that, and use the await. If you don't call the await, actually there's no action is going to be taken by the runtime, so you have to explicitly call the await wherever you want. And either you can split this one into two, or you can just make use of it. This is nothing but is taking the response text and then extracting the content for us. So if you check this one, I think it's showing Rust analyzer is dead here. So I'm going to say it's response login page response, and this has the user token inside this one. So you have to analyze, you have to fetch the user token. So for that we have to create another method, and the better part is function async function. What you can call is get user token or something, get underscore user underscore token. This is the rusty way of doing function names. Do we need the username? No, we just need the response text, response, because we already got the response text here, so we just send it here. And what we need from here is we have to make say a doc that is passing the HTML response that we got. Then maybe you can make use of this one, token selector, pass not security, it was user underscore token that we already checked. And just propagate the error instead of unwrapping it. And now we have the selector, token selector, and now after the token you have to extract the exact token. So this is so much of unwraps here. I think better don't make use of this one. Instead we can divide this because it was inside an input value. So just say let first we select the input as we have mentioned, actually it is input. So we are going to first extract the input field, just say next unwrap here, and let it be the token be the input dot value, otherwise it will be getting confused if you are using it one line. Then we need the attribute value, because it was stored, the user token was stored as an attribute under the name value. So we are taking the inputs, we already selected the name, so the next thing is the attribute that called value. Then take that value, this is enough. We got the token now, and just return the token to string, because you're returning a string here. So in this unwrap is in fact a trap here. We have to properly try to manage the error on later when if you're planning a more serious common vulnerability scanner. You have to properly plan all these things, the error handling. So now you come here, we already have the token, we fetch the token, we fetch correct, then we will do this await, and we got the token after passing the login page response. Then now we need is we have to get into the, we have to log in. For that, yeah, we were using it is saying something like this, but we can properly say login params. Then there are different ways of creating this because the form is accepting a hash map or a tuple. So first I will show how to make use of this format. Here you can pass username as username, password, login. Yeah, we need one more thing. It is user underscore token, and this is token. This is one of the easiest ways to create the parameters for the forms when you are posting the form. Then we can delete this one, we don't need this. So the next thing is we post no, we don't want these kind of stuff. We need to post the form, not the other one that you are suggesting. Yeah, better take this one. Post with the login parameters, send it, await. Again, if you want, you can split it up, the text, but we don't need the text here. I think we just need up to here. We just send the request, and if it is going to be okay, if you want, you can just test that using the login response, and if everything goes well, I think we better check it. Now we have a login mechanism and a get user token mechanism. Let us try to build it, and if you build it, it will be an error, I think. Why the rest analyzer is not, I don't know why the rest analyzer is not showing properly. Maybe it happens when the memory has issues, not issues actually, whenever I try to see, it is not reload the workspace. No, rebuild. Okay, it's not working anyway. Cargo, just try cargo build. Did I do something wrong? Why it is an error here? Does it have any issue with the syntax? I think it's not. Let me check the grades. Just copy this. Sorry. This one. Yeah, now it is. I don't know, there might be some other things. And better if it's showing some errors on the cargo.toml, just come here on the the crate website and copy that from here just to avoid the typos. So it is trying to build it now. The main thing we didn't discuss, we are going to make use of async. Async is nothing but is how it works is like this. Do work while waiting, that's the main thing, and it is there in almost every other languages, but I think not in Golang. Golang is using a different mechanism for that. In fact, that is very clean and very easy to implement and learn. There is no complex cryptic syntax things like Rust is doing. Async Rust is really a big pain, especially to make remember the syntax stuff, how it handles. And just because I'm just started deeper dig into this Rust format thing, is very cryptic most of the time whenever, and is there is no other way other than doing it, actually practicing it, because you have to practice with your muscle memory, otherwise you forget. It is more on knowing the language features other than your stuff to do. There are a hell lot of ways to do some same things in different complicated ways and simple ways, so it's up to you how you're going to choose it. But in async, actually you should know how the async work, because it is very much needed for cybersecurity tooling, because most of the time we need concurrent tasks or parallel tasks to be done, so it is a must to have. So, and Rust basic standard library doesn't have an effective runtime, so Rust is making use of Tokio most, and there are so many other, not so many, some other Rust runtimes are there for async, but Tokio is very well proven and is widely used, so try to make use of that itself. And yeah, and we will be making use of one mechanism called join macro here in this one, because I'm going to show you the async concurrent way, not the parallel way. So we'll be making use of that. We'll come to that soon. So yeah, this is the basic thing about async. It's nothing but do other work while waiting. So, and in Rust actually async is kind of a trait called future, and is called lazy, because if you don't call await, it won't trigger. That is the best part. That's good in a way when we can control that. So come here, it has errors. Maybe this need to have text. Wait, I think that's the only thing that is this consider the login URL as a reference here. So yeah, that is suggested by the compiler. Just try that. It's most of the time it's always good to use this kind of stuff. But now what is error? And in get also the same error. I think that was A that suggested that. Now it is finished. Even though we are using async functions, we didn't make our main async, and async main, then we have to set up our result type as the same result type that we are going to make use of other. So if you make use of this one, this is going to create an error for you. See, the main function is not allowed to be async because, as I said, it doesn't have any built-in mechanism to make use of async. So you have to make use of this declaration, the Tokio main. To Tokio is the runtime that is going to help us to run the async operations. So the compiler now knows we are going to make use of Tokio runtime. So Tokio runtime is going to handle the async functions for us. So now it will build. I think there won't be any error. We didn't have a return type. So sometimes the compiler is very friendly. I think the new version compiler will be more friendly, I'm expecting. Sometimes it's very cryptic. Yeah, now it built. There is no problem with this one. So the next thing we need is we have to just test whether it's going to log in or not. So for that, the first thing we need to do is just declare our web scanner. Scanner initialize the scanner, and just say the scanner, the base URL, just keep it like this, and this is the base URL. Now we have to try to call the login, and yeah, let me did we print? Yeah, we did print it here. So if it's login properly, I think, let us see what is returning. And so it returns something that has, yeah, it is the page that we are seeing. See, it is inside that stuff. We do not responsible. I think that is a page that we are seeing here. It's disclaimer and warning. So many things are here. Yeah, see the warning, disclaimer. So we successfully logged into this one. So the token fetching and the login is working. So just disable this print now. Now the next thing we need to do is we have to set up the DVWA security for us. For that, if possible, we can make use of, let me try with this one. So if we get clarity on this one, so we don't need to make use of the burp suite again, because that is very, I mean, it can control the memory, but it's most of the time it's getting stuck with the issues. So I'm going to do okay, impossible, just submit. So what was the security.php, the requests, headers. Now we just because we set the cookie store as true, we are maintaining the session, so we can make use of the same scanner object for rest of our operations. And if you see, is a post, okay, you have to check the post method and the request. Okay, we need oh, these are the post method, the form that the form, or not the form actually, yeah, the form data that we need. Just like the login, we need security, this sec level submit and the user token. So we need to do that now. For that, okay, let us copy this method. We don't need to waste time on that. Just rename set set security level, and for the security level what we need is, yeah, just the security sec underscore level as the string and nothing else we need. And we should know the what was the URL for that one, and anything else we need. I think no, we just need this one. Yeah, this one is security.php. Just be security URL, and instead of this we can say security level response. And here we will be, we don't need the get. In fact, do we need the get? Yeah, I think we need this application works in a way that every time if you want to get the user token is different on every request, so that's a tricky way. So definitely we need to get first, then and we have to get the token from this one. I think we can verify that here for the get. Maybe here it has that user token here. How to find here user. See, it is here again. It is inside the same name, user underscore token. It's a hidden value, and this is different from the other token that we checked previously. So here also from the response you have to extract the user token, then sec underscore level params, so that we checked here the request form data security. Copy this here, and that is that is comes as sec level, and submit. This value has submit as the value. Copy that, don't make any spelling mistakes here. So once if you're on track, it will be easier for you to move forward. I think user token is going to be, there is no login here in this one. Instead it's going to be user token, and the token we already have. Yeah, that is done. Now once that is done, next is just say sec response and post security sec underscore URL, then form using the security level parameters, and just send and await. So this will set up the security level for us. So after this we will be doing set scanner dot set sec level, and sec level, just for practicing and testing, we start with low, and now we did log into the application, we fetch the user token and set the user level. Now I showed you before on the demo time how the XSS can be analyzed. So we are going to check it in a way that if there is an XSS or not by verifying the response after injecting into the query strings or form field, wherever it is. In real time, if you're trying for a real common web application scan that works for anywhere, you have to, the challenge will be finding out all the forms with all the methods. Then you have to fill all the form or query strings with your payloads. For all these operations, we need async async task stuffs, because utilizing operating system thread is not good for us in security tooling most of the time, because it's very expensive and it will be CPU bounding up things if you're going to make use of threads. It's always good try to make use of async. And yeah, I will be, as I said, we'll be diving deeper into async operations exclusive for cybersecurity toolings in another video. For this one, now we have to check the XSS part here. For that, what I'm going to do, we just start with the reflected one. So is there anything that we can copy from? I think we can copy this again and make some changes. Say what to say, verify underscore reflected. And what we need here, just say target URL, and better we accept the payload also. Target URL next payload. If you want, you can maintain the naming convention by putting the underscore and, after every important word. So this is not needed. The target URL is going to be, suppose if it's reflected, and it is this one. Test how we are going to set up this one is the target URL is going to be this, but here we need the parameter as name. If you want to make use of now we are going to directly give the name, but if at the time of expanding more functionality to this one, the main thing you have to do is you have to dynamically fetch the parameters. Here I'm going to do the parameter name directly, so because we know what, so we don't need this one because it's coming directly as this up to here we are going to get, then we are going to statically set this one. I mean, it's not dynamic one, we are just setting it up from here itself. So let us say we have to create the query string setup. For that we need, there's another way of sending the query string and form data, that's called, basically it accepts what to say, string. Basically the query string or form data accepts hash maps. It's nothing but dictionaries in other languages. It's a key value mapping. So here you can try to make use of that one, because we already did the other way of it's hash map. Then insert the hash map. Here it's called not ID, it's name, and the payload, XSS payload that we need. And now we have the target URL and the payload, and say get request. So try to get the request with the query string. See, this is again this is showing wrong one. We have to pass the parameter. Pass the parameter as reference. Is a str ampersand str type. So the target URL query string, and we are getting the response. Just say XSS test response. Just make it more readable, because sometimes Rust itself, other part of the Rust itself will be very cryptic because of so many symbols. Now we are calling, we are propagating the result from this one, and now we have the response here. Now what to do is same thing. as we manually checked the response is there. When you are testing that in a testing scenario, it reflects on the browser itself, so it is easy to take POC as that. But in this scenario, there are another way of doing it. Using the scraper, you can just check the response and dig deeper into and check exact HTML element is there or not. The same thing can be done using this the string comparison. So now we have the response. Just say if XSS r underscore test response that has the data that we injected, the payload. Then we can say XSR reflected is found. So but our type is OK type, so you have to say it's going to be an OK type with this statement. XSR are found with payload this one, found. Either you can say XSR reflected found with payload, this payload in URL in URL this one, and you can say payload first, then the target URL. Or you can even add the the parameter name. This OK is not OK, this OK. Else again it should be an OK, and say format not found. Just make it clear, XSR not found. With the same thing that you can make use of, so it won't be is not found. This one is it things now it is OK thing, so we don't need this now. Because we have an if else condition that's already satisfying the return type. So if there, in case of error, this will propagate this error and return the error from here. So other conditions, we just checking the payload is there or not. If the payload is there, we are just confirming XSS reflected is there on the response. So now we need to try checking it. Let us say I think better you print the alert of this one and the test URL. This automatically came, that's good. And now we have scanner verify. Okay, we have to get the result from this one. Let res let XSR are result equal to this scanner, and we are calling awaits, and the question mark will propagate the return value, then try to print it, println this one. So if there is an XSS and in this one with the security level low, and if this method is correct, it will find it out. Let's try that now. We just have to make this video as short as possible. Oh no, it has so many errors, I think. Which method is, oh, that is absolutely wrong. It was format, and is that one response contains payload. I think that error propagation is not properly handled. For so we did send that request. So okay, either, yeah, that is a mistake. Either we have to take the text from here after sending it, or just make it properly done in two different steps. Either you can make use of this one, but I'm just, for clarity, I'm going to make use of text response, and this one is going to be this, and we're going to have the actual text response. So that will resolve this issue, I think. Something else is there. Oh no, this should be, yeah. Now since we are returning an OK string, but it was a unit type, I forgot that. Yeah, that is something we should be taking careful. Oh my god, there's another one. Now it found expected. Yeah, this is a Rust way of dealing stuff. Either you have to use semicolon with the return keyword, or you have to completely avoid the semicolon there. Then now what is that? Yeah, this one 47. We didn't use 47. Oh, it's already, it came as string reference, I mean ampersand string, so we don't need to use again ampersand on that. So it is, oh my god, I didn't check what are the other hash map.new. Oh, we had to use this std collection. We had to import this into our project, otherwise the hash map thing won't work. Now how many errors? It's good to have errors and resolve it. I think it's building and it's finished. The web scanner, now run it. Now it says login to, it printed 2 times because we did use it on 2 functions when we copy pasted. I think we had to remove this one, or we can say some other message there. So logged in, and it says it found issue on this one, but to confirm this one, just set up the security level in a different, maybe a high. So normally, I mean, you have to make these things dynamic by accepting from the command line. We already did how to make use of command line arguments. So if you are interested in that one, see now, if you are trying to make it high, it says it's not found. So it's working. So on the low, it is setting as, when we are setting as low, it is finding out the thing, because our payload is there on the response. When you are setting it high, it is doing some kind of encoding, so the response is not there on the output on the response. So it is working fine. So we will do the next thing, like stored one. Just copy paste this and just rename this stored one. And for the stored one, the way of doing stuff is same, but maybe the parameter is different. So if you check here, come here as where is the stored one test and check. So it is stored, sign in, and here here again it is accepting the user token. Seriously, oh my god. Okay, why it is accepting, checking user token every time? Maybe a kind of security they are using inside this one, because it's a hidden field anyway. So let us do the same thing, just try this. So for this one, stored one, it is again going to be it's not a query string anyway, and it's going to be a post request. So XSS this string is parameters, insert this one, just say test, the second one is this one, and that was having the actual payload that we needed to test. So this is going to be the XSS payload. It is coming here, XSS payload, and the third one is button sign here, and the value is sign plus guestbook. Let us see whether this user token is needed or not. I don't know why it is asking every time, or we can give it anyway. We have one function here that verifies the user token. I think can then if that is the case, you have to do a get. I'm seriously lazy to do that, but let us check it here. This is a stored one. So now we have the parameters here, and XSS is a response. The target URL and the token from the response. Here actually we directly did extracted as a text in one single line, so it is fine to pass it here for the token. And the next thing is we have to take the user token and submit it. So this how was this? How did we do that in here? The user token was, it's a pass it as a reference. So now, this should be this one. So we are trying to prepare the parameters, and with all the necessary values that we found from here. Now we are trying to automate this stuff. Now we have the parameters, we got the user token, and we say here as test response, and it is a post, not this one, and it's a form submission, and using not the query string, it is the parameters, access parameters. And this one we are extracting the text in 2 lines that we did for the previous one, so just kept it like that. You can do the same line if you want, there's nothing wrong in that. And here on this one the logic is same, and since the logic is same, you can try to make it using the same method by passing some other parameters, switching between the check, and if it's contained, reflex stored, found with payload, and this target URL, and okay, it's not found. Now we do the same thing. So once you are in track, actually it's going very smoothly. And let's try this one. I'll tell you one more thing. Till now everything is, even though we are using async functions, we never made use of the Tokio's runtime macros or anything to make it concurrent. We will do that later. Once we confirm these functions are working, we will do that later. So let us cargo build, and of course it is showing some error. Here the client, oh my god, did seriously 62 line it says. Oh yeah, maybe no need of that. Is that the only one? Okay, one more. Some other issue. It's saying understand str 162. Bounded is oh, this is something very okay. I think the issue will be resolved with this one. Hey, it says, so can we split up the response as 2, then just like the other one, don't waste, because it's already the video is too lengthy. Either we can, no, I think we did, yeah, it is something very, yeah, maybe this would have worked there, but let us try to do the weight separately here. And just say this text, I'm literally lost on those errors, so just making it simple as possible to just to make use of the worked method that we used. See, it worked. Okay, but still there is a question why it worked on the other method and not worked here. I think some reference issues there, some reference and error propagations. These are very difficult sometimes to handle, so just but once if you start coding in Rust, it will be familiar for you. So initially, yeah, definitely it is very painful experience, but yeah. So why it says reflected, so we have to change. Oh, okay, here that we just did it for both, and stored test, what was the URL for this one? Just this part is different, I think. So here we can just say here the change is here, and the target URL here is this one. So now I think it will test properly. Oh no, again it says reflected. Why did we make some verified? Ah, no, they're calling the same method. Issue of copy paste. Wow, some other issue came. Thread panicked. 7856. 7856. We are not doing something properly on 78. Oh, I think that user token is now showing some issue when we are calling from the stored accesses. Maybe where did we call that? Get user. Okay, let me avoid this one. What happens if we don't have that one? And even we don't need this get. Was that correct? We have to, when we want to debug this, we have to dig deeper into all the issues, and now I don't have time to do that for this video. Oh, see, it did accept something. I don't know how whether it worked or not. Reflected not found, and stored not found because of, is it because of high? I don't know. Let us check. Meanwhile, go to the website and refresh it. Yeah, something injected here anyway. Maybe just change it. It is here. So if you want to release the injected value is done here. So I think there is no need of setting up the user token on the stored submission, but still it is not that payload is not good. I think just try to say 1, that's it, and use a semicolon. Now what happens? Try. Both not found because we set this as high, and if we change that to manually to low and see what happens on the stored, still okay. Let us set it as low. it is found in this one. It says it found in it says both found on the low, so it works. If you okay, let us log out and log in and verify whether it is. Let us set the security. We did all this thing automated, like logged in, set up the security as low, and just stored. See, the injected payload is working, so it is working in fact. So now we know how to check this and how these things can be automated. And this is just a demo of this one. How can we make use of this to structure your web application scanner? For the real the asynchronous task, actually, here we are still doing the synchronous way. Whenever we try to call the await, actually it blocks and it wait for this to finish, and then it goes to the next one. Why? Because everything is going to be on the same thread. We never make use of the Tokio's runtime engine to make it asynchronous. So there are so many ways to do this, and I'm going to show you the best and easy one, but it's not so much effective. It's so much effective in the sense it's going to be on a single task. It's not going to be parallel, or is not creating so many tasks to do your stuff. It's going to make use of the same task. What it's going to do is going to call the first one await, and then if it's going to take more time, it calls the next one. So it is kind of juggling between the function calls. So how to do that is you can make use of a function, a macro called join. So it returns tuple. So just say tuple in the sense it returns. Oh yeah, it is helping us to do this. That's good. Yeah, this is like this. Call this join macro and just call our method. Just careful, we are not calling the await inside this one, because that is done by the macro itself. It will do the await for us, and once the function is done, then it will send you back the result, and result will be respectively, according to the way that you call, it will save the result. So that's how we have to make use of this asynchronous pattern inside the application. Till now we were just checking everything sequential. There was no async. Let us try to build it. It's going to, I think the use part, we don't need anything for that. It's direct from the Tokio itself, so we already referred that in our project. So this is how to make this the simplest way of asynchronous. There is another complicated way. We can make use of different tasks and sharing data between the threads. For that, I have to introduce you some other stuff like smart pointers. If you don't understand that, it will be a mess for you to follow up. So what I'm planning is I will take an exclusive video content for that async task and smart pointers, and how to share data between threads and multi-threading. So it will be easier for you to follow up that one. We will revisit the scanner, then we will do the scanner according to that. Now we build it, just try to run it. See, both says it found, and this one, now your application should say this. See, now we injected 2 times, so it should be showing 2 messages. See, now both are injected and it's working fine. Now it is an asynchronous one. It is running concurrently, not parallelly. Like it is still using the same task, but it is making use of Tokio join macro to run it concurrently. So that's all for this video. I think this was very lengthy one, but yeah, there is no other way to. Some of the stuff that I learned from this one, this one, the stored XSS one, it still accepts without this parameter. So maybe we can confirm this using the bub suite. I don't know, the browser may be showing. I have no idea why it is showing that one, but even when I was testing prior to the demo, it was not asking for this one, the token, but the error was serious. You had to check what the error was. I think this selector is a pain, in fact, if you're trying to do the asynchronous one, because the selector by default is using as RC counter. RC is a smart pointer, but that is not thread safe. So yeah, we will discuss those kind of stuff later on other videos, and we'll be continuing with the other part of the scanner. We'll be developing a full scanner. Now we know this working, so we will try to make it parameterized and try to add more functions to it. To some extent, I'll try to add 2 more functions, SQL injection and command injection. Then we will run this by accepting command line parameters and try to expand the functionalities. So that's all from this video. We'll see it soon with another one as a continuation of this one, second part of the web application scanner. Till then, it's a bye from Root and Out. See you soon.